When we're solving first order linear recurrence relations, we will always have a homogeneous part that we're needing to solve. There's sometimes also a non-homogeneous bit. Let's just focus on how this homogeneous bit works. Remember, homogeneous means that we haven't got anything extra. We only have things that involve previous terms. Okay, I've put a starting point there because that might help us understand what's going on. So in this sequence, let's just write out what would the sequence be. So if our first term is a, then our next term we need to multiply this one by k to get the next term. And then we need to multiply that by k to get the next term. And then we need to multiply that by k to get the next term, and so on. So we can see that we're getting multiples of powers of k. Okay, it's a geometric series here, a sequence here. We're multiplying by the same ratio every time, the same k value. So it makes sense to take a guess that our nth term, remember solving a recurrence relation means finding an nth term, makes sense to make a guess that our nth term is going to be some multiple of some number to the power of n. Okay, and it's kind of obvious hopefully that it'll be k, so we're just going to show that it is going to be k. So if we want this to give us the same sequence as the original, then we have to make sure that it satisfies that recurrence relation. So if this is the nth term, then the n plus 1th term is going to be a times x to the n plus 1, isn't it? So let's substitute this into our recurrence relation. So we've got a times x to the n plus 1 is equal to k times a times x to the n. If we divide everything by x to the n, we get ax is equal to k times a, and we can divide everything by a, which tells us that the x that we use here has to be k, this number we're multiplying by. Now this thing here is called the auxiliary equation. I have to try and spell it. Okay, so if you ever see it referred to, that's all it is. All right, but our solution, our guess, was a times x to the n, so it's a times k to the n. Now this thing here is our solution of our general solution of the homogeneous equation, and we can hopefully, just by looking at that sequence, we could tell straight away that in our guess the thing that we're taking powers of is k. All right, and we can find out the a by using the actual sequence, using one of the terms in the sequence to figure it out. So we call this thing the complementary function, and so instead of writing un, we usually write cn, but it is an nth term. Okay, and it's the general solution of the homogeneous part of our recurrence relation. If we want to find the object constant so that we don't have a general solution anymore, then we substitute in our first term, but we usually do that at the very end.